Okay, so as I said, my name is Miki. It's a short from Michael. And I currently work at a company called 353 Solutions. Up to you to find out why did I pick the number 353. It has a relation to Python. And I'm spending my time, half of it teaching and talking and organizing conferences, and the other half writing books and writing code for customers. I still code daily. I really like it, and that's something I love to do. And I will try to share some of what I learned over the years with you in this session. When in the last years, we are hearing a lot about the term called data science. Data science is about processing and understanding data. And this is one of the Venn diagram about the three major areas that you need to grasp when you do data science. The blue circle on the right side is talking about math and statistics. And a lot of people find this scary. Sorry. But from my experience, it's enough to know a little bit of basic math and a little bit of statistics terms like what is an average to go a long way in understanding data. The second yellow circle talks about computer science, and computer science is how we work with computer, how we write code, how we program. And again, it's good to have a little bit of understanding, but in today's tool sets, it's not really necessary. It's something that is good to have. And usually you go deeper into computer science when you start hitting problems like how do I deal with huge amounts of data? Why is my algorithm running slow? But for most of the use cases that you just have a bit of data, some spreadsheets about sales and you want to analyze them, or some visitor information from your website and you want to see what are people doing there, you don't need to know a lot about that. What's really interesting is the bottom purple. Well, you know, guys in colors. I guess it's purple. That is talking about subject matter expertise. And that is important because if I want to understand what's going on with my sales, I need to understand what is the market and what are sales terms and what is revenue and other terms that are matter to that. If I'm doing online advertising, I need to understand the ad tech area about what is a publisher and what are, let's say, the types of ads that we have, cost per click and cost per view, and et cetera, et cetera. And again, you don't need to be really a good expert in the subject matter, but a lot of time people who come to analyze data, they already have the subject matter expertise. You know what you want from the data, you know what you want to understand from the data, and you just need a little bit of computer science and math to tie them together and to help. If you look at the crossroads between the three circles, there is a unicorn. I haven't seen one in real life, and the same fact that I haven't seen one in real life, I haven't seen anyone who's a master of all these three domains in the highest level. There might be some of them, unicorns out there, but most of the time, people coming from one strong or two strong backgrounds, and the rest they catch as they go on. I come mostly from computer science. I spend most of my time building systems for people who use data to analyze it. So I have a strong background in computer science, how to bring data, working with databases, reading files. And from that, I have a good understanding of the tools that are used to analyze data, but I'm not a mathematician or an algorithm person by nature. So that's where I'm coming from. And subject matter, it depends on what I've done. I've done a lot in my 23 years. So I know about algorithmic trading, I know about ad tech, I know about cybersecurity. I think these are the three big ones I did. But every time and then I'm doing something else. I get bored easily, so I learn stuff, and that's interesting. A quick side note about my English. I'm not a native English speaker, and I spent 8 years in the US, which only made it worse. So feel free to barge in and say, I didn't understand, please repeat that. I'll gladly do that. I'm used to it. My daughters who grew up in the States laugh at my English all the time, so feel free to do that. So when we look at data science, there are several languages that people use to work with data science. You might hear about SQL, you might hear about R, and some other languages, but one of the biggest players out there today is Python. And Python is a programming language. It was not intended to be a data science language at the beginning, but in the last, I would say 10 years, it's a very dominant player there. And you see that also in the Python conferences. So if you go to a Python conference called PyCon, you will see a lot of data science talks. And if you go to PyData or data science conferences, you will hear a lot of people talking about Python. So there's a lot of connection there. And this is one view of the ecosystem that we have in the Python world. At the bottom layer, we have the Python language itself. And it's a programming language. It's pretty easy to understand. And what you will see when we work here with examples that you don't need to learn a lot of Python. You can go deep in Python, right? I teach advanced Python for 4 or 5 days, just about some advanced parts of the language. You don't have to know that. It's enough to know just a little bit to get by, and it's usually will make you productive enough. On top of that, we have some numeric libraries, NumPy, Cython, Jupyter, which is a way to work. And then we have Pandas, Matplotlib, and many, 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 many more. And a lot of people, when they come to this world, they get confused because there's so much variety, so many frameworks, and a lot of them are overlapping because there's no one single authority that is developing that. So if you're an engineer, you're working with MATLAB, there's the kits by MathWorks that they're publishing, and there's one coherent view and packages, and it's easy for you to know. When you're coming to Python, and it's a general problem in open source, it's really hard to know which ones to use. So I will try also to let you know which ones are the big, widely used packages that we're going to use. And we are going to use from all of these in these charts, we're going to use Python, of course, because that's the basic for everything. We're going to use Pandas, which is become the library to work with data. And by using Pandas and drawing graphs, we're going to use what is on left of Pandas, which is Matplotlib, which is a library for plotting. Using Matplotlib by itself can be sometimes tedious. Pandas make it super easy to work. And to tie everything up, we're going to work with what's on the bottom right, which is known as a Jupyter notebook. And really, if you have questions, sorry, Kimberly, but feel free to ask questions. If you see that it's too much, then we'll limit the questions to the end. But I like the interactive nature of things. I like that people asking questions and I'm answering them. It's a very free flow talk. Apart from these slides, we're just going to load data and play around with it. So if you have questions, if you want to some clarifications, you want to know how to do several things, feel free to do that. And sorry, Kimberly. Okay, so Pandas. Pandas is a library for accessing data. It was developed by someone called Wes McKinney. He worked at the time in the finance world, and he was missing some things that what used to be very common then called NumPy, which is a numerical Python. These are matrices which are heterogeneous, meaning everything is a floating point number or everything is an integer there. in pandas and real life data, usually we have a mix of types, right? We're going to look at the taxi data set. So we're going to have at times of the start and the end of the ride. We're going to have numerical values for how long the ride was and how many people were in the ride. And we're going to have some textual information about who was the vendor and maybe other things. So a lot of real world data has a mixture of things, and this is what Pandas gives you. So the basic of everything in Pandas is something known as a data frame. You can think about it as an Excel sheet that you have in memory. With computer geeks, right? So everything is a square. And we have data, columns of data and rows of data, and we'll see that in a minute. Now, the nice thing about Pandas is that it also gives you a lot of capabilities to load data from various sources. So if you have data in CSV, which is a very common format, you go for Excel, you do export as comma separated values. This is a plain text file. It's a horrible, horrible format, but it's very common. Pandas knows how to work with it, and that's the format we're going to work. If you have your data in a database, or it's stored somewhere on Google, or maybe on a web server, Pandas know how to reach out and grab the data from a very large amount of sources and put them in memory. Pandas also gives a lot of ability of computation on selecting parts of the data and running computation averages, finding quantiles, and it also supports nice graphing. So I want to show a graph, and we will do all of these in this workshop, and you can follow along. Pandas makes it super easy. And it really, if you come to people who are doing data science, I'm pretty sure that a lot of them are going to be using Pandas, at least for what we call the first contact with data. And this is the analytics and data exploration. Once we get to what is known as machine learning and other things, we usually involve other packages like scikit-learn and others that knows how to work with Pandas. But Pandas is usually the first one to have contact with data. And for your initial queries that doesn't require sophisticated algorithms like random forest trees or deep learning, Pandas is great. It really will get you along. And yes, Mysql is one of the databases that Pandas can connect to. Any relational databases that Python has a driver to, Pandas can connect to. So we are good there as well. Okay, so I really believe in this a pyramid of how you learn, right? So if you're just going to hear what I'm saying and maybe look at the slides, you'll get about 10 or 20, you'll retain about 10 or 20%. We're aiming to go to the bottom of the pyramid of doing the real thing or simulating the real thing. So I highly encourage you to follow along. You don't have to, but if you do follow along, I think you'll find it interesting and you will learn things. And a lot of time when you're doing the real thing and you find an error and you encounter an error and then you fix it, that's a really good learning experience. There's a lot of research showing that making errors while you do things is better for your learning. And Python and Pandas are really forgiving, so go ahead, make errors, and that's good. Okay, so let's work. What we are going to work with is known as a Jupyter Lab. Jupyter Lab is, if you install Anaconda, you can launch it from the Anaconda Navigator, and you will get this Jupyter Lab. Jupyter Lab is letting you running things in the browser and experiment with Python. It's a really nice tool for data exploration. It's a really bad tool for writing code which goes to production. Because the notebook files, these are called notebooks, we'll see them in a minute, are not Python files. There are some kind of different format, JSON format that the Jupyter Notebook is using. But just for using data exploration, having a look at the data, running some queries, printing out some graphs, it's a really great tool and super easy to use. So that's what we're going to use when we do it. Before we dive in, so this is the site for Pandas. It's pandas.pydata.org. And one of the things about Pandas, it has awesome documentation. Really one of the best documented open source projects out there by far. And I'm going I'm reading a lot of documentation. So I can tell you there's a lot of effort in documentation, in use cases, in showing what to do. I highly encourage you to go out and do that. If you want something which is a bit more structured, Wes, who created Pandas, wrote a book called Python for Data Analysis. I highly recommend it. It's a very good technical book. It covers things end to end. I don't get any royalties from the book, so I highly recommend it. Really, it's a good technical read, and it will give you a lot of insights about what to do. But even if you just go to the documentation, to the user guide, you have 10-minute pandas, which basically in 10 minutes shows you all the basics. And then you can dive into many other things. So IO Tools is about how to get data inside, how to select data, how to shape the data, how to do visualizations, how to work with time series. So we have time series data. And many other things, and really excellent documentation, highly recommend it. So if you wanted to start on the meeting notes, we said that if you want to follow along, one of the best ways is to install an Anaconda distribution. So Anaconda is a scientific distribution of Python. And once you install the Anaconda distribution, you will get the Jupyter Lab, Pandas, and many, many other libraries already pre-installed for you, so you can just do them. It was preferable to do it before we started because it is a big download, but you see it's about half a gig of download, depending on your operating system. But once you're there, you run something called Anaconda Navigator, and it will allow you to open the Jupyter Lab. Another option that you had, if you want, is not install anything. Google has something known as a code collab. Collab is a service by Google that they're using Jupyter notebooks. They look a little bit different than Google shaped them a little bit different. But apart from that, you don't need to install anything. You already have Pandas, you already have there. You need to, uploading files is a bit more trickier, and they give you an explanation about how to do it in the Getting Started guide. But then you just need a Google account and you're free to go. You can start doing everything there. There's no installation, zero, just go from there. I have Jupyter Lab and Python installed locally on my machine. Actually, I have about 7 Python installed on my machine, but that's another story. And we are going to do that. So once you launch Jupyter Lab, you will see this launcher. And you see I have several launchers, but basically once you click on this, which is known as a notebook, you get what is known as a Jupyter notebook. And this is what we're going to work with. Okay, so one thing I'm going to do, I'm going to rename it. If I remember. Rename it. So I'm going to rename this as I'm going to call it Taxi instead of the Untitled one. Yeah. So what do we have here? We have the notebook. We have some, it's like a file browser, right? So this is the notebook I just renamed. So this is my cheat sheet about what we're going to do. And then this is the data itself. And again, in the meeting, there was a link to how to download this data. And there are several other things that I'm not going to go into it. And just for, so you'll see more, I'm going to collapse that thing on the left side and go there. So if you install Anaconda, there is something called an Anaconda launcher. And once you install the Anaconda launcher, it has several tabs. I don't remember if I have it. Let me, just a second, okay? Anaconda Navigator, sorry. It's called Anaconda Navigator. and it's loading. Anaconda Navigator is notoriously slow at loading. But once the Navigator is loaded, you will see that you have these buttons, and you just click on the big button for launching Jupyter Lab, and you can do that. So this is from Anaconda if you're starting with Anaconda. Okay, so what we are going to do today, we are going to look at a data set that is provided by the New York City. So the New York City is providing records of trips from taxis, right? So you have for every year, for every month, you have some records for, it's called yellow, green. I'm not sure about the other two. And this is a data set. We're going to have a look at a part of it. The whole data set is really large, so we're not going to look at all of it, but we're going to take a look at some of the data that there is. Okay, so before we start code, I want to make an introduction about Jupyter Notebook and what we can do. So these cells, this thing is known as a code cell. Right, so if I'm going to do 7 divided by 3, and then I can either hit the run button, or I can do shift plus enter. And if I do shift plus enter, it's going to run the code, print out the output, and then open a new cell so I can write again some more code to do it. So these are code cells. In code cells, we write code. The nice thing about Anaconda, about Jupyter, that apart from just Python, they let you run some external commands. It has something called magic commands and many other things. Another thing is that you can, if you look here on where it's written code, you can switch from code to something known as Markdown. Markdown is a format for writing text that is translated to HTML. So I can write a header, and I can do a list of items, and I can see, say you can find pandas here. And once I'm running this cell, you see this is being translated to nice HTML. So a lot of time people are doing reports with these notebooks. They create a nice, some nice text, and then they have code. Sorry. So for example, people even write books. So there is a book which called the Python Data Science Handbook. I highly recommend it as well, by Jake VanderPlan. Jake VanderPlan is an astrophysicist who uses a lot of scientific Python. And he wrote a full book as a bunch of notebooks that you can open them, and you see everything here he wrote in Markdown. And then you can see the code, you can run the code. It's really nice thing that you can have. You can really open in Collab and write everything there. So you can use these Markdown cells to write things. And of course, because this is for geeks. No, it's A. You can write mathematical notation, and it is going to translate it to a nice mathematical notations. So you can, if you're doing math and you want to explain things, you can write these things as well. This is another language called, we call it LaTeX, latex, maybe, I don't know. And it's very powerful, and you can write a lot of things inside. Okay, so this is a little bit about the Jupyter notebooks, and we're going to exactly. Now we're going to start looking at the data. Okay, so I'm going to say that the CSV file is called, and if you hit tab, Jupyter is going to do a completion for you, and it's going to complete also from files on the disk. And because this file is right on the disk, I can just use it. And from now on, I'm going to refer to this as the file. So before we even start the data, it's usually a good idea to have a look about how much or how big the data is. So we know that we're not going to explode your machine memory before you load everything into it. So if you're using the command line, you can probably check, or you can open the Explorer. I don't think it shows the size, but of course we have Python, right? So we can do it in Python, right? So we import a module called path, and we can get the size of the file. This is in bytes, which does not really help us. So let's have a look in megabytes. So it is about 11 megabytes compressed. So it's going to decompress. XZ is compressing to about 30%. So it's going to be about 40 megabytes on disk. That's the size. So this is something digestible by your machine. This is something you can and now we're going to load the file and have a look at what's inside the file and some data. So we're going to import pandas. And because we're going to use a lot of functions from pandas, we're going to shorten the name to PD. So every time we call a function from pandas, it's going to be pd.something. That's the way we're going to do it. And the first thing, what we're going to do is we call the variable df. Df is a short for data frame. And you'll see that this df a lot when you look at the data science code. That's the usual name that they call it. You don't have to, but that's why people are calling it. And we're going to use the read CSV function to load the CSV file. And this is going to take a bit. You see when there was an asterisk marks here instead of the 6, and on the top right, next to where it's written Python 3, this circle was black. This means that the underlying Python process is busy. This underlying Python process, by the way, is called the kernel. And this means that the kernel is busy. Okay, so now we have the data frame. And now everything is loaded in memory. We can start looking at the data. So one thing we can ask the data frame, what are the columns that we have? Okay, so we can see that we have a vendor ID, we have a pickup time and drop-off time, we have how many passengers, the distance, and several other things that usually don't mean that much to me. So tipping amount, etc., etc. Another thing I usually like to look is about the types. So every column, so the vendor ID is a column, the pickup, all of these are columns. And when you do D types, these are the data types. And this is what Pandas thinking that it loads it from the CSV. And this is one of the reasons why I really don't like CSVs. Inside the CSV file, everything is text. And Pandas is guessing for us. It is doing a guess about, I'm guessing that the vendor ID is an integer. I'm guessing the passenger count is a floating point number, which Looks weird, right? Why would the passenger count be a floating point number? So was there a person and a half inside the cab? Doesn't make sense. Distance is fine to be float, but every time, every variable, it's interesting to have a look and to see what is it, and does it make sense or not. Another thing you can look is some of the data. So you can say, for example, I want to look at the first 5 rows, and Pandas is going to show you the first 5 rows. The first 5 rows, and you see it's rendered really nicely inside the Jupyter notebook. The Pandas and Jupyter know about each other, and Jupyter knows how to render Pandas data frame really nicely. So we see the vendor ID makes sense in integer. These two, they look like time, and Pandas has a specific time type. And when we look at the types here, Pandas mark them as an object, which means that it thinks it's a string. Every time you see an object, it means Pandas couldn't decide and it thought it's a string. Passenger count, trip distance, everything else looks fine. First thing of order is we're going to fix this thing. What happens in CSV files, because everything is text, Pandas is not guessing dates because it has no idea exactly what is a date, and it will take a long time to do these guesses. So this is the command I wrote to load the file. Yeah, I'm sorry, my can I make even more? No, don't want that one. Full screen. Okay, that's as much screen as I can give you. I'm sorry. Maybe like this. No. Okay. So I will collapse this one. Maybe. Okay. So when we look at the head, this is what we got. Right. So we would like to tell Pandas, listen, these 2 columns are actually times and not the dates. So if you look at the Pandas with CSV function, you can see that it has many, 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 many options to do that. Right? So you can say that what is the delimiter? So most of the time it's going to be a comma by default, but sometimes we have tab separated values. Sometimes people use a different delimiter. Should it assume that the first line of the file is the headers, or is it something else, etc., etc., etc. And as I said, everything is really well documented with an explanation of what you can do and many other things. And one of the parameters is parse dates. And this is helping Pandas understanding what are the dates which will parse. So what I'm going to do is I'm going to say that the time columns are this one and this one. Okay. And then I'm going to reload again. So pd.read CSV, the CSV file. And I'm going to tell it parse dates with the time columns. Columns with an S. I told you I'm going to make mistakes, right? So feel free. By the way, if the CSV file is not in the current directory, you can give it a full path to where it is on your disk, and then you can go. And also, I'm going to publish this notebook at the end. I will give Kimberly and maybe she can put it on the notes. I'll put it somewhere visible online, so you can have a look at it as well. Okay, and now when we look at the data types, you see that now the drop-off and the pickup are what is known as daytime 64ns with nanosecond resolution, but this is good. This means that we got the right type. So every time you load some data into Pandas, look at it with really suspicious eyes and saying, does it match my expectations? Do I know what I want to do with it? Do I see some values that do not make sense? Right? And sometimes just from the beginning or the end, it's not a good thing. I like to do something known as a sample, and then Pandas is going to take some random data, 5 random lines from the file and show them to me. And sometimes this will show you some errors that are not visible at the beginning or the end because they are better. Okay, so this is the data frame. The data frame, these are the columns that we have. This on the left side with the numbers, this is known as the index of the data frame. Every row in the data frame has an index. This index can be a number, but it can be other things like timestamps or strings or something else. Most of the time, it's going to be numbers. And these are the values inside. So everything under the vendor ID, this is known as a column. The type for it is what is known as a series. So when I want to access a specific column, I'm using the square brackets. And again here, if you click on tab, Jupyter will auto-complete the column name for you. Okay, so if you look at, let's do this. So we look at, and these are the biggest types, right? So the data frame, the DF is a data frame, and the columns are what is known as a series in Pandas. Series, again, is a series of number of values that are labeled, meaning next to every number, there is a label saying this is, usually the label is the location, so 0, 1, 2, 3, 4, etc., etc. In Python, we start from 0. Yeah, let me kill some outputs so you can have a look at more things. Okay. Okay, so this is 11 is the most important code for loading the data. Okay, so series and data frames. Every data frame basically is a sequence of series, which is a sequence of columns. Each column is a series, and you can access the column by name. Okay, so this is the basic loading of data with Pandas. And now we can start looking at things and start asking things. For example, what are the vendor, or who are the vendors? So I would like to know who are the vendors, what vendors do here. You need to do these 2 lines if you get DF notified. So 2 vendors. So who are all the vendors? And for that, Pandas give us something known as unique. Okay, so the unique values for vendors in this file is vendor 1 and vendor 2. And that's it. Okay, so I just want to know the unique values. We have, right, if we look at how many rows are in the data frame, we have, I always find it hard to do that. So we have 1 million rows in the data frame, right? This is formatting them as with 1,000 separator. And we have 1 million rows in the data frame. but only 2 values for the vendor IDs. The vendors are the people who provided the information about the taxi route. Okay, so a million euros. We'd like to know how many rides per vendor ID, right? So if you're thinking about traditional programming languages, you say, okay, I'm going to create probably something like a dictionary, and then I go one row after the other and increment the counter for the specific vendor, and at the end, we'll do that. And you can do it in Python, but Pandas is a big library. There's usually implementation about anything you need already there. So we can take the vendor ID and we can say we want the value counts. And the value counts, as the name suggests, it is showing us how many instances of each vendor ID we see at the data frame, right? So we have twice as many rides from vendor number 2 versus vendor number 1. Okay, so you see that, and this is usually what I do with data that at the beginning, before I even start working on a specific task. I just load the data, look at it and said, okay, what can I ask about the data? Does it make sense? How can I figure out some things about the data? It gives me a feeling about the data, about the shape of how things are organized there. And then I can go on to do my task. But a lot of time it's just curiosity. Just the other day, we wanted to see which how many recurring customers I have as a company. So I took some data that was stored in Google Sheet, turned it to CSV, ran some Pandas magic on it, and I got the answer. So it took me 10 minutes maybe. So once you know the tool, your curiosity about data is easily satisfied. And this is nice. One thing you can do, for example, is say, it's not really easy for me to work with vendor 1 and vendor 2. That's not really interesting. I would like to convert them to the right names. So if you look at the taxi data on the website, they provide a PDF with explanation of every column. And you will see that they will tell you that vendor ID 1 is called creative, and vendor ID 2 is verify. Okay, so I created a Python dictionary which maps these two, and now I can do create another column in the data frame, again using the square brackets. And I'm going to run again the value counts. Okay, so now it's easier for me to see what's going on, right? It's much clearer than this result on output 20. It's much easier to see that in the output of 21, I have now real names. So it's really easy to combine external data inside the data frame, right? So I just had a look at the CSV. I found out that 1 is creative, 2 is verifone. I did one line to have it. And now when I'm running the calculation, I see that it is more easier for us. And a lot of time when you do these things, these analysis, they are for humans. They're not for computers. So you want to make them easily understandable by humans, which sadly or not, are not as good in number as computers. Okay, so let's take a look at the ride distance. Okay, so we can, we have a trip distance, right? What we can do here is we can do something called a describe. So the vendor names are not made up. I got them from, I went to the site where the CSV file was originated from, and they have a PDF there explaining what are the vendors. And that's where I got them from. Okay, so if you look at describe, describe is going to show us some information about the data. So it is going to tell us that there are 1 million lines, and they're going to say that the average, the mean, is 2.8. And it's a question again of some external knowledge to know 2.8 what, right? 2.8 kilometers, miles. Because it's the US and because I read the PDF, these are 2.8 miles, right? And then this is a standard deviation, and then it gives you what are known as the quantiles, so the minimum value. And this already shows that there are some problems in the data, right? How can we have a negative near distance? Every piece of data that you will get from the real world will be dirty and will have bad data in it. I can almost guarantee that. And this is one of my gripes when people are learning about data science. They usually start with small data sets that are clean and nice and organized, and they have a feeling that that's what happens. If you ask data scientists about their day-to-day work, they will tell you that between 80 to 90% of their time, they are spending in fetching data and cleaning data. That's most of the time. Doing stuff after that it's like 10%. This is the cool stuff of running machine learning and AI and all this stuff. And most of the time is this, and this is usually what they call me to do. So they say, you know, we want our data scientists to do their stuff. You come in, you bring the data, you clean it up, you bring them data that is already ready for them to process and then to work. But you need to be careful. You need to be think about these things and to make sure that the data that you have is clean and makes sense. And be suspicious of everything you get. Really look at it with critical eyes. Even the maximal value looks right. So a ride of 122 miles, 123 miles, that's a long ride. And we're talking about New York City, right? I'm not sure if this is the correct value or not, but we need to check that as well and have a look at that. So the describe really helps you to understand what's going on. Sometimes people like to look at data and say, you know what, I would like to look at it visually instead of like these numbers. It really depends on people. I'm not a visual person, and that's why I'm doing backend stuff, which does not include anything that people ever see, unlike front end who design web pages and other things. But some people really like it. So Pandas has a great plotting capabilities. To make them work, we need to do one little thing. We need to do percent and say matplotlib inline. And this is things that start with a percent sign. They are known as magic commands in Jupyter notebooks. And it's not a valid Python. So if you type something like this in Python, Python will tell you this is an error. But inside Jupyter Notebook, this is fine. And what this command do is telling Pandas to plot, to generate all the plots in a way that they can be displayed on the browser easily. And this is usually done first thing when you load the data. Okay, and now what I'm going to do is I'm going to do again the trip distance, but this time I'm going to say plot, and I'm going to say I want a box plot, sorry. And you see that we get a box plot of the trip distance, which is hugely skewed. Okay, so a box plot, it's really hard to see here. But a box plot is showing you where most of the data lies. So there is a box here, which is the 25th and the 75 quantiles, and you have the median. And then all of these are outliers. So you have a lot of outliers in the data that do not show really well. Sometimes data is something that you want to look at it. So you can say to Pandas that you want to show the y-axis on a logarithmic scale. It's a way to cheat, right? So these 2 points are much further than these 2 points, but it sometimes lets you see data that is really skewed in a better way. And here it's easier to see. You know, this is the median, right? So a median is when we take all the values, sort them, and then take the middle value. 50% are higher and 50% are lower, and it's a good measurement of the data. This is the 75th percentile, again, meaning 75% of the data is below it and 25% of the data is on top of it. And most of these things outside of these are called the whiskers, they are considered outliers, meaning the data that is really further away from the average or the median. Okay, so it's really easy to do that. A lot of people, by the way, don't like to have this output. They just like to see the chart. So we usually add a semicolon at the end, and then we see just the chart without the output. And that's one of the only uses we have for that. Now let's look at the data that is calculated data. Okay, so okay, so trip duration. And the trip duration, we don't have it inside the data frame, but we can compute it, right? Because we have the start time of the drive and we have the end time of the drive, right? So we can do duration equal df, the drop of time, minus df pickup time. And we look at the durations. So this is a calculated value. You can also add it as a column to the data frame if you want to. You can move from here. Once you have the duration and the distance, you can plot the speed and many other things. And the plotting, I'm using a box plot. Pandas has many plots. There are histograms and line plots and scatters and many more. The section about visualization in the Pandas documentation is excellent. Really, there's a lot of things that you can have a look. And again, here we see some stuff that does not make sense. So the minimum is a ride of 0 seconds. Doesn't look okay, and the maximum is 5 days and 22 hours, which I highly doubt it's the right time. Okay, and I'm showing, I like to work with this data set because it's showing you real world data and all the problems that you have inside this data, but you can do it. Okay, let's say that I want to select some data. Okay, so we're going to do a side on what is known as Boolean indexing. Okay, just to understand what I'm going to do. So let's say I have a series of values like this. Okay. Now, when I'm going to do s bigger than 3, I'm going to get a new series with a Boolean value telling me that for every element in the series, does it satisfy this condition or not? So 1 is not bigger than 3, 2 is not bigger than 3, and 3 is not bigger than 3. So the first 3 ones are false, and the rest are bigger than 3, so I'm getting true on them. The thing is, if I'm going to save it to a variable, okay, and now I can use this variable to select only the values I want inside this series. Okay, so basically I'm saying I want only the values inside this series that are bigger than 3. And most of the time we're going to write it like this. Okay, and this is known as Boolean indexing. So we do a computation that returns a series of true and false values. And then and then we feed it in the square brackets to the original series or data frame, and we can pick only values that we want. Okay, so we can say that times not what I wanted. Hold on, I forgot how we called it. Oh, duration. Okay, so so we can say, okay, duration is duration, and we can say, for example, duration is bigger than 0. Okay, and then when we look at the okay durations, we'll see that we get something which has a meaningful value. Sometimes we'd like to combine more than one condition. So we could say also duration is smaller time delta, and let's say r is equal 5. Okay, and now we have only writes between that are more than 0 and less than 5 hours. So Pandas makes it, with Boolean indexing, it's super easy to pick out just parts of the data that you're interested in, right? And we can use this thing also to pick up just parts of the data frame as well. So, oh, I didn't want to do that. Okay, duration dot plot dot box. Oh, there's no numeric data. Right, so these are, Pandas can plot only numeric data. So, minutes. Okay. Oh, it's still very much good. So most of the rides are really small. You know, let's take 1 hour rides. Okay, that looks okay. You see, most of the rides are less than 30 minutes. So we can do that. What I did here, so PT time delta is an amount of time. And when I measure something, right, I can measure it in inches, in centimeters, in nanometers, in parsecs. So the time delta is saying this is the amount of time. But if you want to be specific and get a number, you need to tell me what are the units. So I'm saying I want this duration divided by minutes, so I'll get the time in minutes to do that. And we can have a look at this one. Pandas also have it understands well time. So every time you have Um, um, we can get parts of the time that we want. So if we want to ask a question like how many rides between 11 a.m. and 12 p.m. had more than one passenger. Okay, so the question was, there is a question, why didn't it work before we did this? And the thing is, when you want to plot numbers, what is known as a scalar, without the unit attached to them. And when you have a time delta is just a length, but it's not really a number, because I can say the same length is 1 meter or 3 feet or 12 point something inches, I think. I don't remember. So you need to be very specific. So I need to tell Pandas before it plots them in what unit I want to have a look at it. So I'm using minutes here to do that. So how many rides between 11 a.m. and 12 p.m. had more than one passenger? Okay, so we're going to create our mask, right? So we're going to say that, and we're going to look at the pickup time. To access if you have date timestamp information, you can't do like this. This is not going to work. This is going to complain. You need to tell Pandas that you're looking at a time information. So you need to say .dt. So we want it to be in 11, right? So the hour is in 11, and we want the passenger count to be bigger than 1. And finally, we can say we have 12,197 rides that matches this criteria. So Pandas make it super easy. Once you get the grasp of Boolean indexing, of how to structure your queries, it's super easy for you to select only the data that you want or you're interested in. You can, if you don't want to work in this kind of thing, Pandas also have something called query. And you can say df, and here tip app pickup date time.dt.r equal 11 and passenger count is bigger than 1. And on that, we're going to calculate the len. So it's the same example. So you can write it like this if you find it easier. On really large data sets, the second form can be faster. But the thing is that you lose the auto-completion, and sometimes it's harder to make mistakes. I usually tend to go with these ones, but it's a preference. Whatever you like to do, you can do it, either this way or that way. How are we on time? Woo. Time is flying that we're having fun. Okay, so I'm going to do one last thing, and then I'm going to leave the floor for questions, and if people want me to show other things that we can. Okay, so another thing that Pandas can do is something known as an aggregation. This is known as a group by. When you do a group by, you say to Pandas, take all the groups that the vendor ID is 1 and do some computation on them, and then take all the groups that the vendor ID is 2 and do some computation on them. If you want to say, for example, which day of the week has longer mean right. Okay, So what we're going to say is to the frame, I want you to do group by, and you can either give a column name, but we actually want the pickup daytime weekday. Okay, so it is going to group them. It's first going to pick all the groups for Monday and calculate them, and then all the groups for Tuesday, etc., etc. And then we say that for every group, we want the trip distance, and we want you to tell me what is the average. And once we do that, we will get the weekdays are numbered 0, 1, 2, 0 is Monday. And we can see that the rides on Sunday are usually the longest, which is the weekend, so probably makes sense. Okay, so it's the average there is 3 miles versus Monday coming close after that. But that's roughly. So when you do a group by, you basically get the group of everything, and once you use them, you can apply something. So I'm saying I'm interested only in the trip distance, and please, for every group, calculate the mean of the trip distance, and it's going to present it like this. Okay. Yeah, 0 is Monday. Usually you can do import. So one of the things you can do, so there is a weekday that I think there is there's a day name. So let's change it to a day name. Okay, so now it, I think it will help you a little bit. It's better than the weekday. Okay, so it really depends on what you're grouping by, and you can have a look. The weekdays, right, so typo. Name. Oh my good. Okay, so this is Monday. Tuesday, etc., etc. Right? So, and these are what Python is using. But you can use the day name, and then you'll get a string with the actual day name, which is again easier for us as humans to work. Okay, I'm going to stop here and give you enough time for questions. But I hope that I encourage you to try. I hope that I showed you that Pandas is pretty easy to use. You don't require a lot of computation, a lot of knowledge in Python or programming languages in general. Most of the things I think are pretty intuitive, and once you get the hang of Boolean indexing and what you can do with group bys and other things, and also the plotting that you can show, this is really, really nice, and it will help you. You can add to that for there is a lot of data on the internet right now, right? So this is coming from New York City. It's publishing. A lot of cities are publishing free data that you can access. For example, there is a data set from Boston City about restaurant inspection. So you can find, you can calculate what is the restaurant that I should definitely never go to when I'm in Chicago because it failed a lot of other things. Another interesting site that you might want to have a look is a site called Kaggle. So Kaggle is a site for machine learning. They have a lot of competitions about data science that you want, but they also contains really tons of data sets that you can play around with. Where are the competition? Oh, I need to sign in to, hold on. Oh yeah, okay. So there are many competitions. Some of them carry cash rewards. You see, these one are, if you win this competition, you get $100,000. If you're just starting with data science, no, but several of them are just for knowledge, and they have some interesting. So this is the Titanic. The Titanic dataset has information about every passenger, what their age, where they boarded the ship, what were their cabin, etc., and finally if they survived or not. And then you trying to find out how you can predict, given all the data on a person, if they survived or not, etc., etc. But apart from these things, it's really interesting, and you have a lot of data sets. Companies are putting data here, and you can really take a huge amount of data. There are many, many public data sets, US elections, movies, Amazon. So the data is out there. It's super easy now to get the data, and just a little bit of curiosity, a little bit of pandas, and you can do really a lot of interesting stuff. And for me also, as I said, a lot of time I'm curious about stuff in my company. How many recurring customers I have? How many, which of my video courses is getting more students as time goes by? Which one did not, was worth the investment of time? Many, many other things. You know, you just whip up pandas, some questions, and you can go there. Yeah, a little thing about Kaggle. So the first one that started this method of saying, you know what, I'll put some data out, I'll let people figure out the best way to analyze it and then pay the money, was Netflix. And Netflix did the Netflix challenge a while back, and they said, you know, we have this recommendation. If you like this movie, you'll probably also like this movie. And they said, if you improve our recommendation algorithm by 10%, you are going to get $1 million. And there was a furious competition. It took about 2.5 years. A lot of groups, a lot of smart people, PhDs running all over the place. And then one team won it at the end. An interesting fact about that, Netflix never used this algorithm in production. It was more correct, but in the way that Netflix is working, the amount of data they have and the amount of time they want to people that were needed to investment, they said, okay, it was an interesting experiment. It cost us $1 million, but we're not going to use it anymore. So what I showed you here, and at first the beginning, this is more like playing around with data. Once you want to get to real production systems, you need to start thinking about performance, about accuracy metrics, about many, many other things that are also relevant and also interesting. That's it. Questions? So Kimberly, you said you had questions?
Yeah, there are a few questions that were happening throughout the presentation, but one was, do you find that as a data scientist, do you need to use C2?
Most of the time, no. So Pandas is easy used by Python, but a lot of the Pandas core code is written in C and in something called Cython, which is a mix of C and Python. So the performance is already done for you. There have been very, very small cases when some highly intensive code was needed to be rewritten. Most of the time I pick some other options. So as I said, one of the options is something called Cython, which is an extension to Python. So you write a mix of Python and C and it runs faster. And another one, which is even easier to use, is something called Numba. Numba is something that is known as a JIT compiler, just-in-time compilation for Python. And Numba, most of the time you just do this, which is known as a Python decorator. Just decorate your function and it will run X time faster. So a lot of times I start with Numba. I just do this decorator and I don't need to write any more C. It's really rare that I need to go and work with C.
Cool, perfect. Next question is, can you collect data from MySQL?
Yes, you can. So Python has a way of telling if you are connecting to a database, MySQL, Postgres, BigQuery, Oracle, Microsoft SQL, any relational database, this is how you should behave. And this is known as the DB API of Python. And Pandas knows how to work with it. So once you give a Pandas an open connection to a database, it can execute the SQL query to get the data it needs. And once it's there, it loads it. A lot of companies are using that because the database server is usually strong machines. So they initial SQL query that will filter out and aggregate some data and make it consumable by a single machine. And then they can run everything in memory in Pandas. And I've seen a lot of companies doing it.
Thank you very much. We've got a few more coming in the chat now. Shall you convert to smaller data types upon data loading?
Well, you can do that. You can tell. So if you look at the, so the question is like this. So we look at the data types, right? So the vendor ID is int64, but it's only 0 and 1. So we don't need the whole int64 like to collect it. So Pandas lets you convert data types to smaller ones. Usually, if it's not a problem with memory, I just keep them as is. If it is a problem in memory, you can tell Pandas when it's loading the data, look, I want the vendor ID to be an integer of 8 bits, and then it will save you memory. You need to remember that memory is usually cheap. There is a joke that in Google, they have a sticker on the laptop that's saying, my other computer is a data center. So it's really easy now to go to Google or Amazon or Microsoft and lease a cloud machine that has up to 20 terabytes of memory. That's a huge amount of data. Most companies' data will fit right in without any problem. So a lot of time, instead of doing these micro optimizations, I just go out with a giant machine on one of these vendors, load the data there, run the calculation, then close the machine. Cost me $10, $15 and I'm done.
Cool. Thank you very much. Next question. On what level does it get really complex for the data scientist?
It becomes complex when you want to do things that are not trivial. Let's say, for example, you're looking at data which has what is known as seasonality. So think about views in Netflix. I'm thinking Netflix just because they're on the top of my head right now. If you look at how many movies people are watching in Netflix, you can see throughout the day that there is, probably in the morning it's not that much, in the afternoon more, and then after, let's say 10 p.m. it's going down, and then again in the weekends and holidays it's more. When you're starting to deal with data which has seasonality, which when you're trying to figure out complex relationships between data, this can get complex a lot. But from my experience, as I said, high school grade math, and even less than that, and you can get a lot of insights from the data just by doing that. You don't need to know a lot of statistics, a lot of machine learning, fancy algorithms to get real value from your data. But in some cases, when the relations between variables are not that clear, then you need to probably do more complex things.
Cool, thank you very much. Could you please explain about Boolean indexing?
Yeah, so Boolean indexing is what we said that when I have this S, which is a series of number, and then when I'm doing S bigger than 3, I'm getting Boolean values, right? So Boolean values are true and false. And I can use this as a mask to the original one. So I'm saying like this. And this means that I will get only the values where they're true in here. So I'm going to get only 4, 5, 6, and 7. All of these. Okay, and this is known as a Boolean indexing. This is a way to select data based on certain criteria, and you can take this mask and combine them. So I can combine this one, saying it's bigger than 3 or smaller than 1. I don't have anything smaller than 1, smaller than 2. And that's 4. Okay, so I can combine these to have some kind of a selection criteria. And this is a mini language you need to learn. I will, again, I highly recommend the Pandas documentation. They have a whole section about selecting data and a lot of examples showing out how to do
that. Perfect. Thank you very much. I was thinking that all the links that you shared throughout this, maybe if you send them to me tomorrow, I can send them out to everybody afterwards.
Awesome. Yeah, I will do that.
Yeah, cool. Next question. How good do you have to be at stats to be a professional data scientist?
Yeah, you need to know your basics, and you need to understand not to get fooled by the data. I'm not a data scientist. As I said, I'm not doing algorithm. I'm not doing algorithmic research. So it's hard to me to answer this question in full. But for what I've seen, you need to understand some basic concepts about distributions and probabilities to see that you're fitting or what you're getting makes sense. Right? There's the classic question of if you have a group of 22 people, what is the probability that 2 of them will have the same birthday? And the answer is about 50%, which is surprising to a lot of people. But once you get the statistics, you know that. When people don't know the statistic, they get a group of 22 people and 2 people has the same birthday. They say, oh, I found something really interesting in this data. So you need to know a little bit about that, but it really depends on how deep and how complex the data is. But if you do this, the basics, you should be producing value, enough value with just the basics.
Cool. We're running out of time, but I'll do one more. We had one. What is your advice for aspiring data scientists who work full-time in non-data science roles and are looking to prepare for a career transition in their own time?
So I would recommend just what I said at the beginning. Get some data, get some curiosity, and do some interesting stuff. So in a lot of companies, there is data. I did research about open bugs. So what is the average time to close a bug? What are the bugs that are been reopened the most? I looked at some data from a visitor to our website and say, we're getting a lot of traffic these days. We're serving ads. So most companies have some data, and these are called skunk projects or side projects that you do. And just get curious, get pandas, load the data, play around, and then show some insights to your team or to your boss. And most people really like it. And if it's an actionable data, it's even better. And then you will usually get a green light to continue playing around, and then you can spend some time learning to do that. There are many courses available online. So some of them are free. I think the book that I mentioned, and I'm going to send it again, the Data Science Handbook by VanderPlan, is a great start. And it will give you that. But most of the time is get some data, get pandas, and get curious. And you will find out that, okay, I don't know how to do that. I go online and I find out how to do it. I read about why it's working this way. And then you gain knowledge, which is also practical.
Perfect. I think we'll wrap up there. A few more questions have come in, but I've noticed we're out of time now. So
I'm fine if you want to ask.
Okay, there's one says, do you use R, or does Panda cover all of the needs of a data scientist?
I don't use R. I think I'm not an expert in R, so I can't tell you if Pandas cover everything from R, but I never find that someone telling me, you can do that in R and not in Pandas. Some operations are for people are more intuitive in R because Python is a language, is a general purpose language. It's not language for statistics like R, But on the other side, as I said, a lot of time we spend on loading data and cleaning it, and this is Python really where Python really shines.
Okay, and we'll have one more question and then I will wrap up. And I think this one's got a good one. It says, can you recommend any packages / tools for VS Code for automation formatting of Jupyter notebooks?
Yeah, so Visual Studio Code, Microsoft has a team inside Microsoft that works on the Python extension for Visual Studio Code. And it has support for Jupyter notebooks, for scientific computation. So everything we did here, you can run inside the Jupyter, inside the Visual Studio Code with the Python extension. It can show graphs online like we did here. It has code cells, it has auto completion. It's a wonderful product.
Perfect. We'll wrap up there. Thank you so much for this. There's loads of comments coming in now saying that it was really useful, it was really informative. So a huge thank you. And enjoy the rest of your evening, everyone. Thank you so much.